Now, let me first tell you all a story. Once upon a time, there was a farm where there was full of turkeys. And in this barn, the turkey called it the earth. And for the entire farm, the turkey calls it the universe. And among these turkeys, there's one scientist who was the scientist turkey. And he was all around observing the world all around us. And one day, he found the first fundamental law of the universe. It was that the farmer will come every day at 11 o'clock sharp to feed them food. But this happened and changed on the day of Thanksgiving. Basically, at that day, the chicken were killed, and there was no people who come to feed them food, whatever. So think about that. Wouldn't us humans be like these turkeys? Because we are just maybe the turkey scientists. The kind of fundamental laws that we observe around the universe might be just some higher dimensional organisms that created around us. Humans, nevertheless, has been exploring the universe. The universe is full of mysteries, no matter the fast telescope in Guizhou or the SpaceX initiative by Elon Musk. And we also know more about mathematics. It's ubiquitous in our lives. So how about using mathematics to teach us how to communicate with aliens? I would like to introduce you to two kind of books. One is Project Hail Mary by Andy Weir. And this book was fascinating. It was about how humans can communicate with the Tao Seti civilization without any pre-context and translation. It was entirely using musical and mathematical symbols, and they were able to communicate and not betray each other, basically, and completing a common global issue of eliminating a microbial species from the entire universe that was blocking the sunlight. And even more fascinating was Carl Sagan, who sent an entire box into the universe about all human civilizations' legacies. It's from music to other cultural things like Mozart, and it's about asking all the civilizations in the universe to see how humans has been developed, to see how humans has progressed. This idea is definitely a crazy one. You cannot expect to find a book about how to communicate with extraterrestrial civilizations like a dummy. And it was kind of impossible at first, but it was possible because we can connect to previous theorems and different kinds of connections. One of them I found really helpful is the prisoner's dilemma. The prisoner's dilemma was about, basically you can think about two different agents and each of them can choose to stay quiet during a conviction, or they can choose to confess their crime to the others. You can see that the best possible scenarios occur when both people confess or distrust each other, or both people remain silent. But if people distrust each other, they are more likely to confess, and each of them receiving a worse conviction of 5 years than the others. This can happen in our universe too. Aliens and humans may distrust each other and entirely betray each other, or they might collaborate. So it's important to find the motivations between how we communicate, whether it was for information sharing, it was for communication, or it was for trading and commerce. At first, I found these extraterrestrial civilizations to be so diverse. There are nothing that unites them because these civilizations may be queer altogether. They might have different kinds of resources than human civilizations. They might even look different than human civilizations. They might use chemicals other than carbon as their organic base. But there are definitely two things that unite all extraterrestrial civilizations, and I will explain this simply. One is the Kardashev scale. It's divided into 6 different types, and each type is simply how much energy you can control in the entire universe. Type 2 is about controlling all the energy in the whole star, in other words, the sun. And type 3 is about controlling all the energy in our Milky Way galaxy. Ironically, our Earth civilization is only type 0.7, so there's a lot to go, of course. Another thing that is important is dimension. So imagine second dimension and third dimension. We are a third dimension civilization, so we can see both length, width, and height of this auditorium. So imagine if you see an ant crawling on the ground, they can't see the height of this entire auditorium. So guess what? We'll just see them like ants crawling on the ground. They will have no significance to all of us. That's the same to higher dimension civilizations like 4D and 3D. 4D can zip through the earth and transforms through workholes and time through no effort at all. So basically, they will see us as ants as well. So this brings a kind of inherent advantage over all our kind of interactions. So with these two, we can confidently model different civilization scenarios, how we will achieve the optimum interactions by tweaking these equations. And when I was building these equations, I did have sometimes my brain was muddled because this was entirely a new subject. I would have entire conclusions wrong or relationships between them wrong. And at this time, it was very important to make a mind map of what you're doing, to explain the relationships between different subjects, such as what is the connection between dimension and Kardashev skill. And if you want, and if the equations are incorrect, or if you have a misinterpretation of all the dimensions, you might as well completely destroy all these equations and start from zero all again. Definitely don't be afraid of this. Because if you don't destroy these equations and start over, you don't have the courage, these errors will manifest larger and larger, especially when you start the programming or modeling phase. It will become disastrous entirely. And it will be like a butterfly effect. So it's smaller, but when it's magnified, it will become 10 times or even 100 times larger. Well, we have the model now, but there's another imminent problem. It's about data, because we don't have discovered any extraterrestrial civilizations, no aliens yet. So we don't have reliable data to see whether our model is correct or incorrect, or to test our different coefficients. So I have the solution of trying different cross-disciplinary data sets to making more estimations, though they are not really accurate, because you can see I can make data sets and apply them from historical events to economic events, from like when we are calculating equations about war and combat. It focuses on the capability difference between different civilizations, and also for example, the natural resources they have. This is entirely very similar to how humans communicate and combat each other in the two world wars, for example. And these kinds of developmental costs can also be related to GDP and economics. And it's also very important to actually take agency in your search for the data. When I was searching through Google, I was fascinated to see that there was an initiative of what I was doing. It was called Berkeley's SETI at Home project. And using this project, everybody can use their personal computers, and they can contribute their own bandwidth to process the data of exoplanets and all the extraterrestrial civilizations. They can even find aliens using their computer bandwidth at home. So this makes us a very collective rather than a very broad kind of initiative. So even though you can see that this website is now shut down, I just tried co-mailing different kind of organizations like this and say, hey, I have this project. Do you want to help me? And basically, unfortunately, I got no reply. But think about it. If you send cold emails to 50 of these organizations, you'll definitely one day get some results, right? So if you're the lucky one, then congratulations, because you can utilize some of their data. You can even check whether some of your working and assumptions are incorrect. It will greatly accelerate your work, and it will make sure that your work does not have the errors that can be easily fixed or identified. Now, try explaining this kind of theorems that the high school students can do to astrophysicists. That's impossible, right? Because they will be speculative. people said that this is entirely not accurate. It lacks empirical research, it lacks peer review, and everything is not scientific enough. What are you doing? And I said, because such a breakthrough is also commendable, I chose something that no one has ever attempted before and try to interpret it using the high school student's perspective. And they said, well, that project is kind of great, but how can we apply it? That's not realistic. And I said, well, imagine a day where aliens land on Earth and all the government officials, they will have nothing whatever to do or to actions to do, and they will rush towards me because I'm the Earth's only self-proclaimed interstellar diplomat. And at that time, I may be saving the humankind from all kinds of disasters, from revealing our coordinates too far away to basically destroying our civilizations by higher dimension aliens that had havoc on my entire civilizations, destroying all the things over us and take over the Earth as we know it. You can imagine this is quite difficult. But after 200 lines of simulations, after work from all over the year, from last year's summer holiday, I finally got this model. The results were absolutely magnificent. Because I'm not going to go over the results too much today, but here are two quick takeaways. The first one is that lower dimension civilizations won't necessarily be defeated by higher dimension civilizations. This is because if we would unite together, we'll have some population forces, and yeah, we can defeat the innate high dimension civilizations that see us as an ant, because we have in that entire population's communities, we can defeat some more stronger people. And the second is resource specialty encourages peace between us. Imagine if Earth specializes on tomatoes and potatoes and the Martians specialize on cucumbers. So you can imagine how we will all be depending on each other because we will have the resources that others need and we won't be able to produce them. So the key takeaway is, if you want peace, then definitely do some trade. So we might all be turkey scientists in our own mind, no matter how we're trying to make different patterns and kind of do some small breakthroughs from 1 to 1.01. But we are all being successful. We're defining the concepts of the entire science, and we're doing so. But increasingly now, science research are coming to become a checklist on our common applications, maybe just something that we view as a task. We view as something that we must be successful in, and we need to do it as time efficient as possible. But something I need to say is that we need to do something that is fundamentally creative, not just changing or tweaking words on previous papers. But science will only thrive if we do something fundamentally new. If you don't do the research paper yourself through all the difficulties, you won't feel the kind of pleasure after you complete all the papers and all your kind of experiences. And also, in our AI world that is increasingly connected, cross-disciplinary skills is as important as ever. So it's very important to think that science is a culmination of unsuccessful attempts. It's a culmination of failures. You don't need to be very ashamed about making mistakes or even doing something that is criticized by the senior scientists. Just try your best job. Remember that science thrives only when we dare to think big, and nothing is possible. Everything, if we try, is possible. Thank you.